In this video, we will practice graphing sine and cosine functions with changes in the amplitude, the period, and phase shift, and also some reflections over the y-axis and reflections over the y-axis. I should be pointing at this one, and reflections over the x-axis. Okay. You will hear me referring to the the A value, the B value, and the phase shift and any vertical shift. So these are the things I'm talking about when I talk about A value, B value, etc. So on problem number 21, the A value goes right here. There is no visible A value, which tells you that the amplitude must be 1. Now, there is going to be a B value. Normally the B value is going to go right here outside the parentheses. Now, we're going to have to do something special with this because this 2 is going to turn out to be the B value, but we are going to have to factor this out. We really need this 2 to be outside the parentheses to reveal what the actual phase shift is. So I'm going to come back to that. We're going to have to change the form around a little bit. But we do have this K value. This is going to be a vertical shift, so things are going to move up 1. All right, so we're going to deal with all of that. All right, to show you how to rewrite this equation properly, we need to do a little background discussion. I could factor this using the common factor. So I see that there's a common factor of 2. So I could bring this 2 outside of parentheses, and I would have x plus 3. Now this was very obvious, but sometimes I say things like this. Hey guys, if I want to know what goes inside the parentheses, I will take this common factor and divide with it. So that gives me the x plus 3 that goes on the inside right here. Now, thinking of it that way will help me understand what to do if I wind up with numbers that are not so obvious. So imagine that instead of 2x plus 6, what if I had, let's say, 2x plus 7? But let's say for some reason I still really wanted to pull that 2 outside of the parentheses. I could, even though it's not a common factor, I could pull it out as long as I use the same procedure that I did over here. When I pulled out the 2, I divided everything by 2, and that's what told me what to go on the inside. So if I'm going to pull out a 2, I still need to do that. I'm going to divide both of these by 2, and that tells me what will go here. So these 2's will still cancel, and I will have x. But for this, I have no choice but to just leave it as 7 over 2 like that. Okay, now that you understand that, we are ready to talk about rewriting this equation. So if I have 2x minus pi, okay, so if I have 2x minus pi, if I really want to pull out that 2, I can. All right, as long as, just like I did on the previous 2 examples, I divide each of these by 2. So if I divide by 2 here and I divide by 2 here, what is that going to give me? So that is going to give me x minus pi over 2. So guess what, guys? This is the form that you have to write the problem in before you can start talking about what the phase shift is. It has to be in this form with the b value factored out. All right, so if you have a b value, you have to factor it out before you talk about the phase shift. Okay, so going back to this problem, I had to rewrite it. So this problem becomes, hold on. I need to write with finer ink. So this problem becomes y equals the sine of. Now I'm factoring this 2 out. So I'm going to have that 2, and then I'm going to have x minus pi over 2. And then plus 1. All right, so I just did just what I showed you. I pulled out the 2, but then I had to divide by 2. So now we can talk about the period and the phase shift. So this 2 right here is the b value, and that's going to indirectly tell me the period. So remember, the period is always 2 pi divided by the b value. That means the period is going to be 2 pi divided by 2. So the period will be pi. So, okay, so I know the period will be pi. Now that I have factored out the b value, as I must, I can see that the phase shift is not pi, but rather pi over 2. Now, because the phase shift is positive pi over 2, that is crucial. This is how we label the x-axis. We will start with the phase shift of positive pi over 2. Okay, so let's get our x-axis going. All right, so here is my x-axis. Let's see. I'm going to leave space over here for the y-axis. So I'm going to put my first mark right here. And like I said, we start at the phase shift. So I'm going to put pi over 2 right here. Now I'm going to put down 4 more marks. 1, 2, 3, 4. So this will represent 1 full period. So each of these 4 marks represents a quarter of a period. So to find and label the other marks, I need to know how much a quarter of a period is. Well, since the period is pi, then a quarter period, all right, which I'll just do this calculation over here. A quarter period is going to be the period divided by 4. So the quarter period is going to be pi over 4. So that means to get from pi over 2, to get from pi over 2 to the next value, I need to add a quarter of a period. So I need to add pi over 4. All right, now we really need like denominators in order to add these quarter periods. So to make like denominators, I would need to multiply this by 2. Alright, so if I multiply this by 2, just sort of temporarily, then we can see that this mark is the same thing as, let's see, 2 pi over 4. So that's another name for the same thing. So if I take 2 pi over 4 and I add 1 pi over 4, that should give me 3 pi over 4. So I'm going to have 3 pi over 4. Now if I add another quarter period, that would be 4 pi over 4, which is just pi. If I add another pi over 4, that would be 5 pi over 4. And if I add another pi over 4, that would be 6 pi over 4. But this reduces down to 3 pi over 2. So these are the marks that we will have. Now I'm just going to erase these extra marks and get them out of my way. Alright, now I'm going to temporarily put a y-axis, which I know is going to be somewhere over here to the left. I don't know exactly where. But I'm going to put a y-axis over here. So here is my y-axis. So let's put some marks on this thing. So be careful. We have a vertical shift of up 1. So that means that the midline will not be the x-axis anymore. The midline is going to be up 1. So if I put a 1 right here, this is going to be the midline. Okay, let's see. What color should I use for the midline? I think I'll use the blue. So if you see this blue mark, that's not blue. Then this is going to represent the midline. Alright, there's my midline. Now the amplitude is still 1. So that means if I go up 1 from here, that should be where the highest point of the function is. So if I go up 1 from here, of course that is 2. So that's going to be the high point of the function. So I'm just going to put another little dotted line as a guideline here. Alright, this is not mandatory. You have to put the dotted line for the midline. Alright, but the dotted line I just put at 2, you don't have to do that. If I go down 1 from the midline, then that's going to be just 0. So we're doing the sine function. So we know that the sine function starts at the midline. So remember, we had decided to start at the phase shift of pi over 2. So the sine function starts at the midline. So you know how normally we start at 0? Well, this time we're going to start at 1 because of the phase shift, because of the vertical shift up 1. The midline is now here. So we start here, and then the sine function goes up to its high point, back to the midline, down to its low point, and back to the midline. So this sine function is going to look something like this. And that's it. So that was problem number 21. Alright, should look very much like this. I almost forgot. I said I was temporarily putting this y-axis down, but then I just left it. So let's go back and be a little bit more careful about where we put the y-axis. And here's how we do that. This is a positive value on the x-axis. I'm going to put more marks to the left until I get a negative value. And then that will show me where the y-axis should be, somewhere between a positive and a negative. So remember how I used the quarter period of pi over 4, and I added pi over 4 4 times going to the right? Well, if I want to make additional marks going to the left, then that's going to be subtracting pi over 4. So that's what I'm about to do. So let's put some additional marks on here. So let's just do one at a time. So here's a new mark. If I were to go in this direction, I need to subtract pi over 4. So remember, I need like denominators, so I would have to multiply this by 2. So remember, that was the same thing as 2 pi over 4. So if I do 2 pi over 4 minus 1 pi over 4, that's going to be 1 pi over 4. So this mark right here is going to be pi over 4. Alright, so that tells me I need to put one more mark down. So if I subtract another pi over 4, so pi over 4 minus pi over 4 is 0. So that tells me that the y-axis is actually going to be right here. Alright, because this is 0. Okay, so that works out great. So there's my 2 and my 1. But now I can see that this is exactly where the y-axis belongs. All right, let me just erase these extra marks. Okay, so that is what a really good graph should look like. Okay, number 22. This negative sign right here is going to be a reflection over the x-axis. So let me just make a note of that. This is going to be a reflection over the x-axis. Bam. Okay, however, the a value is negative 1, so the amplitude is still going to be 1. Now the b value is going to end up being this 3. But before I judge the period and the phase shift, I really need to rewrite this function. So I cannot leave it as 3x plus pi. I must factor out the 3 outside of parentheses, like this. Okay? And that's allowed as long as I take this 3 and I divide by 3 in both places. So these 3's will cancel out, and that will give me x plus, and then in here I will have pi over 3. So 3x plus pi is the same thing as 3 times parentheses x plus pi over 3. This is the form that you must use before you start talking about the phase shift. So as I rewrite this equation in the new way, I will think of it this way. Y is equal to negative cosine, but then I'm going to have 3 times x plus pi over 3, like I just said. And then I still have this minus 2. All right, I have to rewrite it like this. So now I can talk about the period and the phase shift. The period is going to come from this b value, which is right here. Okay, that is my b value. And but the way I get the period is I do 2 pi divided by that b value. So my period is going to be 2 pi divided by 3. So that's the period. It should be 2 pi over 3. Now the phase shift is going to come from this right here. But it's the opposite of what you would think. So the phase shift will be the phase shift will be negative pi over 3. So negative, whoa, that's too big. Please stand by. Gotta make this smaller. So the phase shift will be negative pi over 3. Now, let's use that phase shift to mark off the x-axis. So here's my x-axis. All right, so let's say negative pi over 3 will be right here. So always put your first mark at the phase shift. So negative pi over 3. Then put 4 additional marks. So 1, 2, 3, 4. That represents 1 period of this function. So since I have 4 spaces, that means that each space is a quarter of the period. So that reminds me that I need to figure out what a quarter of the period is. I feel like changing colors also. So quarter period, I will call that QP. All right, well, the period is 2 pi over 3. So therefore, a quarter period is going to be 2 pi over 3 divided by 4. Now, a long time ago, we learned that if you want to divide a fraction by an additional number, all you really have to do is put that number in the denominator. So if I want to take this and divide by 4, I simply put the 4 in the denominator. Now I'm dividing by 4. So that means that my quarter period is going to be 2 pi over 12. And that's going to simplify down to pi over 6. So I have a quarter period of pi over 6. So what I need to do now is I need to add pi over 6 to figure out what the next mark is going to be. So I need to add pi over 6. However, I need like denominators here. So to get like denominators, I really need to multiply this by 2. Alright, so that means this mark right here is really negative 2 pi over 6. That's another way of thinking about it. So if I take negative 2 pi over 6 and add 1 pi over 6, well, that's going to be negative 1 pi over 6. Alright, so that's negative pi over 6. Okay, if I add pi over 6 to that again, alright, so I'm adding another pi over 6. Well, negative pi over 6 plus pi over 6 is 0. If I add another pi over 6, that will be pi over 6. If I add another pi over 6, that would be 2 pi over 6. And I put it up there because I know I'm going to reduce it. So that's going to reduce down to pi over 3. So now I have every mark labeled. So I'm just going to erase the extra stuff. When it comes to showing the y-axis, this one's going to be a little bit extra easy because the y-axis should be right here at 0. So that means that the y-axis is actually going to be right here. Let's see. There is a vertical shift of down 2. So that's very important. So let's go ahead and do that. So if this is negative 1 and this is negative 2. So let me go ahead and put a little negative 2 right here. So this should be the midline, alright, because of this vertical shift. So like it did on the previous problem, I'm going to use a dotted blue line to represent the midline. So this is the midline. Okay, now the amplitude is still 1. So that means when I put my dots, when I graph the graph, it's just going to be 1 up and 1 down from the midline. So right here is negative 1. So this is negative 1 as far as the y-axis, and this is negative 3. Alright, so we definitely want to label those. So I think I'll put an extra little guideline down here just to help me do a better graph. Alright, there's not really space for me to do much of a dotted line in here. Okay, but I'll do my best. Okay, now it's time to do the graph. Be careful. This is a cosine function. So you know that a cosine function normally starts off at its highest point. However, this negative sign in the front is a reflection over the x-axis. So instead of the cosine function looking like this, the cosine function instead will be upside down and it will look like this. So that means the cosine function needs to start at its lowest value. So I'm going to put my first dot right here. Remember, I'm starting at the phase shift, which was negative pi over 3. So I start at its lowest value, and then it should go to the midline, and then it's going to go to its highest value, back to the midline, and then back to its lowest value. Again, because the cosine is upside down. Alright, this is a little bit hard to draw because of the delay. So that is it. That is what this problem should look like. That was problem number 22, and it looks like this. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.